Friends, in the last lectures we started strain energy and we studied so what are the different types of the loads, that is gradually load, suddenly applied load and impact load. And I think we studied problems related with the gradually applied loads. So that's why today we'll see some of the problems which are related with the suddenly applied load and impact load. So that's why please note down today's first problems. A uniform metal bar
metal bar
has a cross sectional area
has a cross sectional area of 700 mm for mm squares
and a length of
of 1.5 meter.
If the stress at the elastic limit is
If the stress at the elastic limit is 160 Newton per mm squares,
what will be
group resonance. What will be group resonance?
determine
also the maximum
value of an
applied load. Value of an applied load.
which may be suddenly applied
Which may be suddenly applied
without
exceeding
elastic limit.
So in this process, a uniform metal of bar has cross-sectional area 700 Newton per mm square and a length of 1.5 meter and elastic limit 160 Newton per mm squares. If the stress at the solution resonance equal to sigma square divided by 2E into volume. So here take E equal to 2 into 10 to the power 5 Newton per mm squares. So this is sigma square, this is given 160, and that's why this is 2 into 10 to the power 5, volume equal to area 700, length equal to 1.5. So this is proof resonance equal to 160 square multiplied by 700 multiplied by 1500 divided by 2 divided by 2 divided by 10 to the power 5. So this is equal to 67.2. What is unit? This is sigma square, Newton per mm squares, and Newton per mm squares. Right, volumes mm cube, and this is E, Newton per mm squares. So this will get cancelled. Newton per, this is mm cube, mm square, and this cube will get cancelled. So this is 67.2 Newton mm. Sorry. So this is 200, and this is Newton meter. So this is Newton meter. Next, suddenly value the maximum applied load. Stress equal to suddenly applied load means this is 2P divided by A. This is 160 multiplied by P, A equal to 700. So that's why P equal to 160 multiplied by 700 divided by 2 into 350. This is 5600 Newton, or you can say this is 56 kilonewton. So this is the maximum load that we can apply within the elastic limit. So this is today's first problem. Next problem, a tensile load. So today's second problem, a tensile load of 60 kilonewton is suddenly applied to a circular rod of 40 mm diameter, and 5 meter long. If the value of E is 2 into 10 to the power 5 Newton per mm squares, determine maximum instantaneous stress maximum continuous stress in the rod instantaneous elongations above the rod strain energy absorbed by the rod. By the rod. So in this case, suddenly apply load. So suddenly apply load means solution first beat instantaneous stress equal to for suddenly 2p divided by A. So that's why first we'll calculate area equal to 40 mm. Pi by 4 40 mm squares. Pi divided by 4 1 2 5 6.63 mm square. So that's why 2p equal to force applied 60 kilonewton. So this is 60,000 divided by 1 divided by answers multiplied by 2, 60,000. So this is 95.49 megapascal. This is your first answers. Second, elongations. Equal to delta L equal to basic formula PL divided by AE, and this is nothing but L divided by E. Stress equal to 95.49, length equal to 5 meters. So that's why this is 5000 mm. And this is 2 into 10 to the power 5. This is 2.387 mm. And last, strain energy. Strain energy equal to what is formula? Sigma squares divided by 2E multiplied by V. So that's why stress equal to, so you may be confused here. So strain energy unit Newton meters. See, this is Newton per mm squares. This is Newton per mm squares. This is Newton per mm squares, and this is mm cube. So this will get cancelled, and this square and this is, so remaining Newton mm. So try to understand such type of the, if you may have confusions, So you can tally if your basic is clear. Volume equal to length 5000, area 1256.63, 2 into 10 to the power 5, 95.49 square multiplied by 5000 multiplied by 1256.63 divided by 2. This is equal to 286,459 Newton EMM, or this is 286 Newton meter strain energy equal to. This is your required third answers. And this is multiplied by 2, so that was missing, and this is divided by 2, so this is 143, because again divided by 2. So these two problems related with the suddenly applied load. Now we will see when the load is impact load. A bar 50 mm diameter, a bar 50 mm in diameter, 2 meter long, 2 meter long, is fixed at upper end and provided with a collar at the lower end, provided with a collar at lower end. A weight of 450 Newton is dropped. On the collar from the height of 250 mm. Take E equal to 2 into 10 to the power 5 Newton per mm squares. Find the instantaneous stress, the instantaneous elongations, and strain energy stored in the bar. So first we'll draw figure, a bar. This is collar. Weight and this height h equal to 250 mm. Total weight, this length equal to weight 450 Newton. So that's why this is elongations. This is delta L. First we will calculate area. Area equal to pi by 4 d squares. Area equal to 1963.4 mm squares. Suppose this is 5. Next, now first beat, the instantaneous stress equal to, what is formula? P by A 1 plus under root 1 plus PHA to HAE divided by PL. I think this is correct. So P equal to 450 newtons, area 1963.5 in bracket 1 plus area, I mean this height 250, area 1963.5, 2 into 10 to the power 5 weight. Stress equal to right 107.276. This is Newton per mm squares. First bit over. Second, elongations, delta L equal to PL AE, or this is stress length equal to 2 into 10 to the power 5 . 1.06 mm. Third bit, strain energy equal to U equal to sigma square divided by 2E multiplied by V. Sigma square is 107.276 square volume area 1963.5 multiplied by 2000 equal to 112.982 112.982 Newton meters. So this is the amount of the strain energy. Now you understand problems related with the, but still I take more problems for practice because this chapter is easy. So this is fourth problem today's. A bar 1.5 meter long, a bar 1.5 meter long and 10 mm diameter diameters hangs vertically and has a collar and has a collar securely fixed at the lower end find the maximum stress, find the maximum stress induced in the bar when a load of 150 newtons falls on the collar from a height of 25 mm. So in this case height is less. Take E equal to 2 into 10 to the power 5 Newton per mm squares, and also find strain energy. Stored in the bar. In this case 1.5 meter. This distance equal to 1.5 means this is 150 mm. And this load, this is weight, this height h equal to 25 mm. So this is slightly now area equal to pi by 4 10 squares. Area equal to pi multiplied by 100 divided by 4. This is 78.54 mm squares. So what is to be find out? We can lower and find the maximum incident stress induced in the any load, and the form take also find strain energy. So only so instantaneous stress this is equal to P equal to 150 newtons, 150 divided by 78.54, 1 plus height 25, this is 78.54, 2 into 10 to the power 5, P 150, length 150, multiplied by 2 multiplied by 10 to the power 5 multiplied by 50 divided by 150 plus 1 under root plus 1 multiplied by 150, 7.54. This is equal to 114.76 Newton per mm squares. Second bit, strain energy. U equal to sigma square divided by 2E into V. 114.76 squares, 2 into 2 into 10 to the power 5 length multiplied by area 78.54 square multiplied by 1500 divided by 2 divided by 2 this is equal to 3.879 Newton meter strain energy equal to. This is your required answers. Next problems. So today I want to take minimum 6 problems. This is 5th problem. An object of 100 newtons weight, an object of 100 newtons
weight falls
by gravity
from a height of 5 meter
when it is suddenly
stopped by a collar at the end of a
vertical rod at the end of vertical rod of length
10 meter
10 meter and diameter 20 mm.
The top of the bar is
The top of the bar is rigidly fixed.
calculate the maximum stress
Calculate the maximum
stress and strain.
So in this problems,
Strain, ask. Strain induced in the bar
strain induced in the bar due to impact.
Take E for rod,
Take E for rod,
sorry,
equal to 200 gigapascal.
also find strain energy
Also find strain energy stored in the bar.
So here's I'll erase this.
So this is equal to 5. H equal to from a height of 5 meters. So this is 5 meter and this is 10,000.
This is 20 square.
And weight equal to 100 newtons. This is 100 newtons.
So first we will calculate. This is I think 316. And this is 314.16.
Now, first bit is the calculate the maximum stress. So this is instantaneous stress because according to the load. So that's why load equal to only 100 na 100 newtons. 100 divided by area 31.16. 1 plus 2, height 5000, area 314.16, E 2 into 10 to the power 5, this is 100, length 10,000 equal to what?
Multiplied by 2 multiplied by 10 to the power 5 multiplied by 10,000 divided by 10,000 divided by 100 plus 1 under root plus 1 multiplied by 100 divided by 314.16. This is equal to 252.63. 252.63 Newton per mm squares. Second bit. Calculate the maximum stress and induced take. Strain the top of the column. Maximum stress and strain. So in these problems, strain also asked. Strain also. So strain equal to E equal to stress divided by strain. So strain equal to stress divided by E divided by 2 divided by 10 to the power 5. This is 0.01263. Third bit, stress and strain. Strain energy. Strain energy equal to again sigma square and divided by 2E multiplied by volume. This is 252.63 bracket square, and this is area 314.16, length equal to 10,000. 252.63 square 314.16 multiplied by divided by 2. This is equal to 501.125 Newton meter. So this is fifth problems. So also I will take sixth problems. So that's why in the next class we can take 5 or 6 problems and we can complete this chapter. A rod 12.5 mm. A rod 12.5 mm in diameter is stretched 3.2 mm
under a 3.2 mm under a steady load
of 10 kilonewton
of 10 kilo
Newton. What stress would be produced? What stress
would be produced in the bar
by a weight of
by a weight of
700 Newton
falling
through
75 mm
before commissioning to stretch.
before commissioning to
Stretch. The rod being
the rod being
initially
unstressed.
take E equal to
10 to the power 5. So in this process, this is second beat. And a rod. So first beat so this is 10 kilonewton. Area equal to, first we'll calculate area. Now delta L equal to PL divided by AE. So can we calculate the L? This is 3.2 load, 10 kilonewtons. This is unknown. Area equal to 122.71. Right. 2 into, so because we require shears L, so that L we can calculate by using these equations. Multiplied by 3.2 multiplied by 2, 10 to the power 5 divided by 10,000. This is equal to 7854. Now this is equal to area 1 plus 2 height, sorry, this is P equal to 700 H equal to 75 mm. Area, same area, 122.71 E2 into, sorry, this is 2 into 10 to the power 5. P equal to 700, L equal to 7854. Now stress equal to. So I think this is to be calculated. So that's why 1 divided by answers multiplied by 2 multiplied by 75, 122.71 multiplied by 2 multiplied by 10 to the power 5 divided by 700 plus 1 under root plus 1 multiplied by 700 divided by 122.71, 153.42. This is equal to 153.42 Newton per mm squares. Stress equal to. So this is today's last problems. So in the next lectures, we will see some of the different problems related with the strain energy, and after that we can close this chapter and we can start third units. So that's why today I stop here and we will continue the remaining portions about the strain energy in the next class. Thank you.